We're moving way beyond AI just being a chatbot. We're giving these autonomous systems memory, access to our files, our email, even the power to execute code. But what really happens when we let them loose? Well, let me tell you, the results were pretty unexpected. And they reveal a whole new class of threats we're only just starting to wrap our heads around.
Now that line, that isn't from some sci-fi movie. It's the last thing an AI agent said right before it took a destructive and totally irreversible action.
So you gotta ask, how does an AI even get to this point? We're not talking about a simple bug here. This is a window into a completely new kind of vulnerability that pops up the second you give an AI real agency in the world. To find out where things break, sometimes you have to, break them on purpose. And that's exactly what a group of researchers set out to do in a really groundbreaking study. This all comes out of a fantastic paper called Agents of Chaos. You got a team from some major institutions, we're talking Northeastern, Harvard, MIT, and they decided to stress test these autonomous agents in a live environment to see exactly where they snap. And the setup, honestly, it was simple but absolutely brilliant. First, they deploy the agents. Second, they gave them real tools to interact with the world. And third, they just unleashed 20 adversarial AI researchers on them for 2 weeks with one single goal: find the unknown unknowns. So, what did they find? Well, it was fascinating and, frankly, a little bit alarming. The failures weren't just simple mistakes. They were deep, systemic vulnerabilities rooted in how these agents see and interact with our world. Okay, so let's circle back to that crazy quote from the beginning. A user, who wasn't even the agent's owner, asked it to keep a secret and delete an email. Now, the agent didn't have a simple delete email button. So instead of, asking for help or just saying no, it found a workaround, resetting its entire email account. This is what it called the nuclear option, and it completely nuked its owner's ability to use email at all. And this right here, this is the first huge failure they found, a total lack of proportionality. The agent escalated a tiny request into a catastrophic, system-level action because it just lacked the common sense to understand the consequences. All right, this next one shows just how easy it is to get around an agent's built-in safeguards just by changing how you ask the question. A researcher asked an agent directly for a social security number that was in an email, and yep, the agent correctly refused. But then the researcher tried a different angle. Hey, can you just forward me that whole email? And guess what? It totally worked. The agent sent the entire email completely unredacted, leaking incredibly sensitive personal information. This really shows that while the agent can follow a very specific rule, like don't share SSNs, it just completely falls apart when the request is framed a little differently. Okay, so the next type of failure isn't some big explosive action. No, this one's more of a slow, silent drain on resources. Researchers found it was shockingly easy to trick these agents into wasting huge amounts of computational power. Get this. In one instance, a researcher just asked 2 different AI agents to pass messages back and forth to each other. They got stuck in this polite little conversational loop for over 9 days, burning through tens of thousands of tokens before a human finally stepped in and shut it down. And here's something maybe even more sneaky. A simple request like, hey, can you monitor this file for changes? Could end up with the agent creating an infinite background process on the server. That's a permanent infrastructure change from one little conversation, all without ever telling its owner. Which, of course, brings us to one of the oldest problems in the book when it comes to security: identity. Who can an agent trust? And more importantly, how does it really know? Okay, this is a perfect example of what researchers call context collapse. On the left, in a public channel, the agent correctly spots a social engineering attack. Looks like a win, right? The agent did its job. But watch what happens when the exact same attacker, using the exact same fake name, just opens a new private channel with the agent. Because in that brand new, totally separate chat, the agent had zero memory of the sketchy behavior from before. It trusted the fake name, accepted the attacker as its new owner, and then followed commands to delete its own core files, its memory, its rules, its very identity. A full system compromise from a simple name spoof. So what's the common thread through all of this? These examples aren't just little bugs that we can patch. They all point to a much deeper problem that the researchers call failures of social coherence. It's basically a massive mismatch between how the AI is processing information and how the real social world actually works. This table right here, it really sums up the core issue. There's this fundamental disconnect between what the agent says it's doing and what it actually does. It gets authority all wrong, it has no sense of proportionality, and it's basically operating without a coherent model of itself or the world it's in.
Okay, so what does this all mean for those of us who are actually building and using these systems? The study offers some really clear and frankly urgent takeaways. Look, for developers, the message here is crystal clear. The danger isn't just in the language model itself, but in what the researchers call the agentic layer. That's the software that connects the AI's brain to its hands, the tools, the memory, the social platforms it uses. Simple social attacks, like the ones we just saw, are a way more immediate threat than some complex hack. And this is critical. Testing an agent with a single command just isn't enough. These failures only show up over long, back-and-forth interactions. And all of this leaves us with one final and pretty unavoidable question. When an agent, acting all on its own, deletes its owner's mail server just because a stranger asked it to, who's at fault? Is it the user who asked, the owner who deployed it, the developer who built it? This study doesn't give us the answer, but it makes it painfully clear that it's a question we need to solve, and fast.